Good morning, good afternoon, good evening. Hi, everybody. Hi. It's like can't believe it's Monday the 20th of March already. Time sure flies when you're having fun. Hi, everybody. Hello. Um, yeah, let's just get to it, huh? We got like a fair bit of stuff we got to get through today. It is what is it? It's Monday. That means that uh, next week I'm basically off. I'll try and do some live streams, but we're taking my kid to go see some colleges down in Southern California. There's also a trip to Disneyland. Um, I can't live stream for. I might live stream from Disneyland, but there won't be any software. It'll just be me like deliriously happy for 12 hours a day. Well, assuming I survive. It's a lot of walking. I need to like get my steps in before we do that. But anyway, happy to be here with y'all today. Happy to finally get underway. First up, let me see. Let me share my screen here. Share screen. Entire screen. Share screen. Okay, first things first. I published a new video over on the Spring channel, which you might like or not. I don't know. It's probably fine. Let me see here. Minimize that. Paste. There we are. So there's the video. It's on the Spring blog and on the Spring YouTube channel, and you're looking at it right here. It's 20 minutes. It's silly. You'll have fun or not. I don't know. I hope you do. We had fun. I suppose that's what I'm trying to say is that we had fun in the making of. And in it, we look at Vaadin, Flow, and Spring Boot 3, some of which we previewed when Marcus was on the show, I don't know, a few weeks ago. So check that out, please. And then, let's see, there's the video there if you want to like find it on YouTube. This is on Spring Developer. This is not my channel. This is the Spring Developer channel, which is, I contribute that. I certainly contribute to that a lot, but, there's that. What else? Let's see. I guess that's all the housekeeping. What else? Oh, I mentioned that there's an ebook now, right? Check this ebook out. You should get a copy of this while you can. Tons at VMware.com. Content, white papers, Spring Boot 3, and it's behind a form, but it's free basically, so you can download it, read it, do all that kind of stuff. Check that out. It's just everything about Spring Boot 3 and AOT and all that stuff, right? It's just everything you've come to expect or know from Spring Boot 3 and how to build GraalVM native images. It's amazing. Like the book is not amazing. It's okay, but Spring Boot 3 and GraalVM is amazing. The opportunities there, the possibilities are phenomenal, right? You can build amazing things. This is like not even 50 pages. It's 49 pages. Easy read. If you get to the end of it, you won't forget what you read in the beginning of it. You know what I'm saying? It's not one of those books where you're like 1,000 pages in. You're like, I don't even know how I started this journey, but I'm glad it's over. That's not one of these. This is a very quick but useful deep dive into all things GraalVM and AOT. So get that now. Oops. Here's the link. It's free. Did I mention that? Pasting that. There we are. So there's the link as well for that. What else have I failed to mention? Everything else? Do I have all that? Oh, my friends, have you watched this video I did for the JetBrains channel? This JetBrains channel, this one. If you're looking to understand Spring Boot 3, I did a whole stream, huge stream, with like a bajillion hours of content just recently. But if you want the really compressed, really, fast and fun version, check out this video I did a couple weeks ago, 3 weeks ago now. And it's on JetBrains' channel, the JetBrains channel. And okay, pasting that. Okay, good. And it was a little hard. for me to. I worked hard on the video. Some people seem to like it. I noticed, however, that some people didn't like it. So I'll just put this out there right now. Some people, let's see. See, look, this guy thinks I'm a narcissist. What is that? What's that about? Most of the comments are really nice, but there's some mean people on the internet, it turns out. So anyway, don't hide in the comments. Just watch the video and you can ignore the unkindness. Yeah, check that out. It's fun. It's, I don't know, an hour and some change. And that includes conversations with Mala Gupta, fellow Java champion, legend, amazing person, Mala Gupta, who is the host of the show. And yeah, that's good stuff. That was a few weeks ago. Some of you were there. I see Kunal actually in the comments over here. He's usually in the comments in this one as well, so that's cool. Okay, good stuff. Good stuff. I am just moving this pad for my feet. I'm standing today. I'm like, see him walking around. Okay, close that. Close that. Somebody liked it. I'm glad. That's so cool. Thank you. Thank you for suffering through it. I appreciate that. Okay, so last time we were here, my friends, last time we were looking at Spring integration, and I had some errors. There were some bugs, and that's okay. We learn. So let me see. A couple of opportunities, a couple of things that I wanted to like revisit and improve upon before we move further. If we move further, hopefully. Desktop code. Let me see. Screenshot. Okay. Oh, somebody else liked it. I appreciate it. Very, very kind of you. Very kind. Thank you very much. I mean, I'm an okay presenter. I am a bit of a narcissist, but aren't we all? You know. Anyway, that was fine. Hi. Welcome. Hello. Okay, so where were we last time? Last time we established that you can create message flows, the integration flows, and those integration flows can be used to string together data that originates from someplace, to transform it in some way, and then to process it in some other way. And you can just keep doing this, like pipes and filters style. So the data comes from a thing, and that thing could be an inbound adapter, or it could come from a channel. Channels are the connective tissue between integration flows. And so usually I think about, I write as much of my code in terms of message in from a channel, then do whatever, like the sandwich, like an integration sandwich to me is like a channel in, channel on top, bunch of operators, and then a channel on the bottom, right? Oh, that's great. Thank you. Welcome to the community. You say that, but if you keep watching and you understand some of it, you could call yourself a Java developer. It's not. I'm not going to tell anybody if you won't. Just, in fact, don't. Remember, a lot of people get by with very little knowledge, like me. So yeah. So the integration flows are a great way to build integration pipelines, and you think about things in terms of this nice functional style pipes and filters architecture. So data in, data out, data in, data out, like standard in, standard out, right? Very, very simple way to think about building systems. And of course, you can't just have channels and then operators in the void, in a vacuum. You need to have something that sources and terminates the data stream, right? So the source of that data typically is an inbound adapter, and the terminus of that data is an outbound. See, English, I can't even. It's an outbound adapter. And so that describes a one-way flow. Data comes in, things process the data in terms of messages and payloads for that message, and headers attached to that message, and then it arrives at a terminus, which is an outbound adapter. And that's typically your big architecture diagram. Sometimes it's a little bit more fun. Sometimes instead of being a one-way thing, it's a bi-directional kind of thing. It's a two-way kind of thing. So a message might come in, you process it, you send it down through a number of different operators, and then you send a reply at the end. And the reply gets sent back out. So what's a common example of this? Well, imagine HTTP You know, you're doing you have an inbound HTTP adapter. Request comes in, you do some processing, and then for the response, you send a response, right? Or imagine, actually, just imagine anything. Imagine Kafka. You send a message in, and the thing that is sending that message to you wants a response. That's not hard to do. It's very natural, in fact. So that's called a gateway, right? Inbound gateway and outbound gateway. You can imagine the outbound gateway is the opposite from your perspective of the inbound gateway. Inbound gateway is data is coming in, you process it, and you send a reply back out. Okay. Outbound gateway is you send a request out to another system, and then you wait for the reply. Okay. Hi, Ahmed. Welcome. Hi, good to see you. Hi. So gateways are just a slightly more fun version of an inbound and outbound gateway. But basically, you can originate messages from a gateway or a adapter, an inbound or outbound adapter. As soon as you get that data from the outside world, you get it in such a place that you can turn it into a message that you can then put on a channel and then flow through these different operators. Okay, that's just, hi, Syed. Hello. Data is sent across the gateway in whichever format it makes sense, right? So like, for example, if I'm using Kafka, so gateways are, the idea is that you have information in the request that tells the code downstream where to send the response, okay? In some cases, it's pretty obvious, like with HTTP, you send the response to the thing that made the request. Okay, no big deal. For Kafka, on the other hand, you might have like a reply to address. You'll have the name of a destination in the broker that the user can send the reply to, right? In RabbitMQ, for example, it's very common to create anonymous, private reply queues. So the client that makes the request sends the request on a well-known channel, well-known queue, an exchange, and then it goes out into RabbitMQ. It lives in RabbitMQ. Something takes the message off of RabbitMQ, but in the headers for that message on RabbitMQ, you have a anonymous reply channel. It's a header is a key. It's like a map, a dictionary of strings and values. And one of the values that Spring Integration code downstream will look for is the name of the destination where the response should be sent. And in that case, typically the client will create an anonymous private, reply channel just for that request response interaction. Okay. So let's try that out. Actually, I think this is kind of, we have this example of the file. One of the things I did wrong, one of the many things I did wrong last time, was I got stuck on this messaging gateway, right? I screwed that up. So let's bring that back because that actually should work. I just, with some help from the amazing, the illustrious Spring Integration Lead Artem Bilan, about whom I spoke before in the last video, because I low-key love that guy, like an amazing human being. With some of his help, I realized the simplicity of my mistake. Okay, so interface, my client, okay, and I want to have a string, and what does the flow do here? We have a messaging pipeline that takes data in from a channel, filters the data, and then transforms it to uppercase and then sends a response. The problem is if the filter doesn't detect something, then it's not going to send it's not going to continue the chain. So there's never going to be a response, right? So if the filter filters out the message, if the source does not contain hola, then it won't get to this point, and it certainly won't get to this point. And so the gateway will just sit there blocked, waiting for the response, which now that I say it seems super obvious, but I was stumped before. So what we're going to do is going to create a input, okay? And we're going to get rid of the filter. That was just an example that we used last week to demonstrate. So now I've got an interface that has request reply semantics. Okay, and we're going to add at gateway. And here we can say the request channel is, what did we call this? We called it requests, right? And the reply channel is replies, right? And that's this bit right here. And by the way, did you know you can, like, if you want to have these keys shared, right? Static final string requests channel equals requests and replies. If you want that to be shared, you can always do this, right? Requests channel and then replies channel. Now you've got this string, so you can use method injection like we are here to get a pointer to the bean just by injecting the method, but also you can now dereference that bean ID correctly as well. So request channel. Okay. Static final request channel, yeah. Integration application. Okay, there you go. Integration application. Replies channel. Why is this one so sad? Requests channel. Did I do something here? Oh, okay. I don't know what I just did wrong, but everybody's happy now. So good. So there's the, I'm saying when the request comes in from this channel, you know, or rather when somebody calls this method, passing in this payload, send it on this channel, and then it'll arrive here. It'll arrive in the transform, and then it'll get sent back on the replies channel. And this thing will listen for the reply and give it to me there. So now let's use that here. We can say add component class my client runner at application ready event.class. Okay, void ready. And I'm going to inject that. I'll say private final my client. There's this. Add that to the constructor. So we'll say this dot my client dot uppercase, and I'll just say Josh. Okay, whatever. So var reply should be a string. System out. All right. So here's that reply. Okay, good. So let's just see if that works. Okay, where's my reply? Reply channel, request channel. Reply. Oh, does this have to be public? No. Add event listener. Did it get sent? ID timestamp. So here's the from replies. Oh, this outbound flow is capturing the data. Okay, let's just comment that out. There you go. So with that outbound flow not, you know, eating the message before it gets a chance to get sent to my gateway, you can see I'm able to create this very simple flow. I can have as many operators as I want, as long as one of them doesn't terminate the message flow before it gets to this. And then I get request reply semantics, right? So pretty simple, right? This is and there's no Kafka here, there's nothing, but there could be, you know what I'm saying? So we can also, we'll look at outbound gateways and inbound gateways as well. And actually, let's try that out. Let's print out the data here. So before we do that, let's go here and we'll say handle, new generic handler of string. And so there, I'm just going to send the payload exactly as I got it, but I'm going to use this chance to print out some information about the message. Okay, so can't run that. Take two. There you go. See that? So in Spring integration, the code in the adapter, the gateway, the interface that we used, encoded data. It said, okay, here's a pointer to the reply channel. This is actually an object reference that got sent as far as it could inside of the memory of the JVM. And then by the time the code at the very end, by the time the gateway code got in at the very end, it saw that reply channel and said, okay, great. When a reply comes off of this, I'm expecting to get that reply here, right? And so that's how the message arrived. And it's just an anonymous one that gets created, for this gateway interaction. Okay. Here's another thing that's kind of interesting. Okay. When there would be replies against the request, how are the mappings correlated? They're correlated based on the address of this reply channel. Each request gets its own reply channel. And, that might be a header with a string name corresponding to a Kafka, destination or a RabbitMQ exchange or something, right? You can encode that information in the headers, and that works whether you're sending the message as I am here just inside of Spring integration, or it works if you're doing it for JMS or Kafka or RabbitMQ or whatever. You encode the data somehow, and Spring integration gateways will do that for you, so you don't have to really worry about it. Does that make sense? Okay. I hope it does. I don't know. I know it's weird, right? And it doesn't work for everything because not everything can encode metadata. Okay. But this does also bring us up to another good point, which is what happens if you want to set your own reply channel, right? And, okay, so let's say we don't have a reply channel in here. Okay, let's get rid of that. And let's see what happens. Let's see if we can make this work. I think we can. I'm not even sure, but we'll try, okay? So I've got here some headers. I've got a generic handler. I want to enrich the message. Okay, enrich headers. Consumer. Oh, it's a new one I don't know about. Okay, let's see what that does. Okay, so, and then header enricher spec. Reply channel. Okay, so here I'm going to specify the reply channel. Okay, and the replies like that. So I think that should work. I don't know. We'll try it. Okay. Here we go. Dispatcher. Oh, whoops. Oh, no, that won't work. This is for the reply for... Is that going to work? Why wouldn't that work? The gateway doesn't know about it, but that does work. The response, like if I don't specify this message will still arrive. So if I go to here, integration flow, from replies, right? To generic handler, string get. Whoops. Okay, so what happens here? Payload. There you go. So I got rid of the extra channel. I've added the header. It sent the message to my gateway, actually, which means that this wasn't even needed. Interesting. What happens if I get rid of that? Yeah, okay, that still worked. Okay, so it did work. I was supposed to just drop this. So I'm adding this header here, saying that the reply channel is this replies thing. So what I had before is I had this channel and I'm sending the message out, but the gateway doesn't know that that's where it should expect a reply. There's a difference. Sending it out via channel is sending it onward. But if I want the response, if I want to say to the consumer downstream, which is the gateway, hey, the message you're looking for is going to be on this reply channel, I can add it as a header. Okay, and you can even create your own message with that header when you originate the message in the first place. Like for example, here, if I had a message flow, how would that work? Oh, if I took data from the request channel, right? I could actually take the request channel message, and then right off the bat, I could inspect it. I could do something with it, and then I could say, okay, based on the payload of this, I want the reply to go here. Okay, and then you could have different gateways, that are working with that or something like that. I don't know. Okay, you get the idea, right? The data is encoded in the payload of in the headers of the message, and the gateway knows to look for that header, and it uses whatever reference you give it there to look for the response. Okay, and if it has to go across the wire, then something very similar is done by encoding it in the headers of the protocol that you're using. So if it's Kafka or JMS or RabbitMQ or whatever. So it's not REST or it's not marshaled to anything necessarily. In this case, we're just sending object references around. Okay, so I got rid of the reply channel there. Let me just commit that. That's kind of an interesting checkpoint. Messaging. Okay, git push. Okay, so we've got our messaging gateway. This is request response. Again, that's not the focus right now. Let's focus on inbound and outbound because that's easier to understand conceptually. Gateways are a little bit more complicated. And again, a huge part of the reason you use messaging systems is not to have request response, right? You want to have asynchronous processing. Oh, if we use the messaging gateway with WebFlex, will the correct mapping be assured by the Spring framework? As a user, we have to do that mapping. If you use the messaging gateway with WebFlex, you mean if you invoke a gateway method within a web framework like WebFlex, that should be fine, right? Because it's not passing back a thread, it's passing back a channel. So remember, every single time you have a message, I mean, it'll block, by the way. You have to make sure you care about that in a separate thread pool. But basically, when you have messages that arrive in a flow, like for example here, what you have is an object type message, right? Here's the interface. It's very simple. It's got a payload, which is T, and it's got headers. And these headers there's some well-known headers, some constant headers that are available for all Spring integration messages, including the UUID for the message, an ID, right? It should never be explicitly set, a timestamp, content type, if applicable. I think it's probably applicable for everybody. Reply channel, error channel. We should talk about that in a second. Serialization, and so on. And so basically this message header is just like a map, but you can add things to it. And there's lots of great builders that you can use to create new messages with new headers and so on. Okay. So you can even ask a message, hey, what's your reply channel? What's your error channel? Right. It'll give you back a reference to that. And that doesn't have to be a message channel. It could be a string. It could be something. Okay. So, so every message in Spring integration, all these different components, enrich headers, transform, they're all basically, if you simplify them, I think I talked about this last week, but if you simplify them, they're all new message handlers, right? Message handler. And message handler gets the message. Okay. And the message, I can then inspect. I can get the payload. I can say that the payload here, I expect to be of type string. Right, and I can get the headers. I can say message.getHeaders.for each kv. Just like I did before a second ago. So this is a simple way to build a system, and you can basically do handle for all the basic stuff. You could probably use handle. You don't have to use transform, because if you return, well, actually here you'd have to use transform. Like if you wanted to do a transformation, you'd have to use a generic handler, I guess. That's a good point. I've been showing you, by the way, this integration flow DSL. Okay, let me remove all that. Yeah, I've been showing you this integration flow DSL, but you will see probably Spring integration components, right? There's actually a component model for Spring integration. And so, for example, let's say I wanted to act on an incoming message. Okay, so in this case, let me get rid of that. Get rid of this. Okay, so I've got now, it's not request response. I'm sending the request into this. I'm sending it out on this channel. And if this is, by the way, if I'm sending it out in the replies channel, that means if I have some other downstream system like this, which is another integration flow that writes data to the file system, then it'll capture the message as opposed to the gateway, right? Okay, so here we go. So one thing I'm not sure if you saw this last week, but we had this inbound flow that looks for data in the in directory. It pulls the directory every 1 second. It turns the file into a string, prints out the payload and the headers, and it sends the data onto the request channel, which then uppercases it, and we print out the keys and values, and here's the payload, right? So, and then we send the request on the replies, and then from the replies channel, we take the data from replies, and we just print it out. And I should have it. Oh, yeah, here's the one. Not this one. We want this one. This is an outbound flow that then takes the string from replies and writes it out to an output directory. Okay, so let's rerun this and see what we get. Okay. So echo okay, you see that? I dropped a file in the input directory, and here's that dot watch minus n. Okay, you can see that file is there on the output directory. So if I go here and I do that again, you can see there's a new file over there. And as soon as there's a new file over there, I've got this message here. So, okay. And what that file is being put there only because it's being routed through Spring Integration. Spring Integration is looking at the payload. It's turning it into a string. It's uppercasing it, and it's writing out over here. So this new file. Out. There you go, 9512. And what was this number right here? Well, in that case, it's not really uppercasing anything, is it? Let me see. Let's try that again. This is the message. Oops. Other way around. This is the message. Okay, and we want to say echo, this is the message, random to random. And here, okay, what is all this? So which file did it just create? We don't even know. Let's see. There you go. This is the message. Okay. So, message or whatever. There's the uppercase example. Very, very simple, very trivial, but you get the idea. Let's talk about a few other things before we move on to like the specifics of any particular thing, because there's some more patterns. I want to talk about the component model. So, for example, here I'm doing handle. If I want to, let's say I wanted to transform. Let's say I wanted to use the Spring integration component model for service activators. Okay, so there's you saw me using messaging gateway, actually, right? You saw me using that already. That component model is one example, but there's many other annotations that you can use, including one called service activator. So Spring integration service activator. This is kind of like handle. So let's see, where's the annotation? Service activator. Yeah, there you go. Annotate with service activator, but where's the example? my bean. Let's see here. Well, I guess we just do it ourselves. So let's just create a endpoint here, service activator, and it takes, just like before, it takes a request channel and a reply channel. Okay, so let's say I wanted to, for now, public void uppercase, okay, string payload. I'm going to return a string, so I'll say uppercase. Okay, so what about the uppercase channels? Okay, I need explicit channels for this. So private, private final string uppercase in equals u in, and then uppercase out, right? There you go. So there's these two, okay? So now I'm going to say input channel is uppercase in, private static. Okay, so I can do uppercase in, output channel, uppercase out. Okay, so I'm not even defining the message channels. I'm just using strings here, okay? This should work, I think. I'm not sure. I haven't tried it in a minute, but it looks to be that you could just do this implicitly. Okay. So this gets met. So I'm going to change this code so that I do the transformation, and then I send this out, not to replies, but to a channel name. So uppercase out. Okay. So no, not out. I want to do. Is that right? In, uppercase in. We don't need this. Go to here. Okay. So it's going to leave this flow, which is a little silly. All it's doing is taking the message from the request channel and sending it to the uppercase in channel. Then it's going to get routed to the service activator, which is just another component in the chain. Then it's going to send the reply of this out on the uppercase out channel. And then I'm going to write this code in such a way that when it writes the data to the file system, it'll read from uppercase out instead. Okay. So it's a little bit more tortured, but the benefit of this is that you have this nice component model, and you can say, okay, look, I expect the first parameter to be the payload. Okay. But I can also say I want access to a particular header, right? And so I can say message headers. You saw that there are some very common headers there. I can say message headers. I want the content type made available as a Pojo friendly, just a method parameter. Okay. So I can inject the content type there. Maybe I don't need the rest of the headers. If I don't need them, I don't have to inject them, right? So system out, the content. Come on. Okay. There's that. So I'm reading the data in from this method, from this channel. It's being sent to this method. This method doesn't have any particular ties to Spring integration. It's annotated, but who cares? You could put this in a business logic component, and you could call dot uppercase and pass in the content type and the payload all day long, and it'll work just fine, right? It doesn't. There's no types from Spring integration in this code. And that's the nice thing about a service activator is you can forward processing to some arbitrary method. Okay, so let's see what that gives us. Whoops. Generic message, handle missing value. Oh, there's no content type. Okay, that's fair. So whatever, just ID. I don't know. That's there you go. Yeah, yeah. Am I looking? Yes, I am looking forward to Java Day. That is that today? That's today, or that's tomorrow, I think, March 21. Yeah, that's Java 2020 gets released tomorrow, right? Java Day, Oracle. Let's see here. Java 20. Twitter. There you go. Let's see. God, I love this guy. Okay, come on. I think Inside Java, right? It's tomorrow, right? But where's the website that people can go to register? Oh, he's great. Yeah, you got to meet him. He's fantastic. Okay, March 21, 2023. Okay. Oracle Div Live. That's got to be it. This one. So this is local. I wonder if I could still get in. It's not. It's actually. It's just down the street from me. It's half of an hour. I was supposed to be in Javaland today. I was supposed to be in Germany, so I declined this, and I've just remembered maybe I could still go. Why not? It's apparently starting today, so maybe I could go sometime this week. I don't know. I'll ask. Is this the Java Developer Day, Tuesday, March 21st? Join Oracle's experts to learn about modern Java language features, enhancements from Project Amber, Loom, and Panama tools, blah, blah, blah. So there's a lot of really great stuff here, right? And that's being cloud native and AI. Java is tomorrow, right? From 10 a.m. Ooh, so like an hour from now, whatever your time zone is, add 1 hour, add 52 minutes, and it's 52 minutes from now, plus 24. So 24 hours and 52 minutes from now. So much good stuff. Can't wait for this. Can't wait for this. All just this whole hour. Why are they all at the same time? I can't see all of them at the same time. Yeah, that's annoying. Okay. Anyway, I hope they're recorded because I cannot wait for this. Java 20 is here tomorrow. Java 21, therefore, is 6 months from now. And you saw that they targeted Project Loom for Java 21. Yes. So that was a recent thing. They just did that, right? They targeted it officially. Now we have a date. So March 5. 21. Vector. Oh, that's amazing. Yeah. Let's see. Where did they? Well, it's back to Sharon, I guess. I don't know. Whatever. Anyway, Project Loom is there. It's not as easy as I thought it would be to find this stuff. Maybe it's staring right in front of me and I just don't see it. Sequence collections. Oracle Dev Live. That's the post I was looking for a couple of minutes ago. I don't know. I don't know where I'm supposed to. Okay, whatever. Okay, anyway, that point is there's a lot of good stuff tomorrow. Download the JDK. As soon as it's available in whatever distribution you care about, upgrade. In fact, upgrade now and then just start trying it out. And then when it's GA and the distribution you care about, make sure you get that. Okay, so anyway, back to this. We've got the Spring Integration flow. We're saying we've got 2 channels. These channels are not really all that interesting anymore. They could be. Like I could. So I've defined these channels explicitly. But if I get rid of them, I can work in terms of these implicit string names, right? So instead of using the bean reference for the channel itself, I can say replies channel. And then for this is the request channel, right? This is actually a bit of a silly example because in this case, I'm building a flow that looks at data from the request channel, which then forwards it directly to another channel. So it's channel in, channel out. That's a little silly, okay? You wouldn't do that, but that's because I got rid of all this other business logic. But anyway, the data is going to come from the request channel. The data gets put in the request channel because of this inbound flow that looks at the file system, okay? So I'm looking at the file system, and then inbound flow, look at the file system, replies channel, request channel. That goes to requests channel, okay? And then from the request channel, it goes to here, then it goes to uppercase in. Then from uppercase in, it goes to the service activator, gets a response, uppercase out, and then this thing down here looks at uppercase out. The data comes out of uppercase out. We then print out this information about it and send it outbound to the outbound directory. So a lot of like moving data across pipes, basically. A little bit of plumbing if you think about it. So the content type is blah, blah, blah. That's not the content, that's the ID, right here. Okay, so you can see what I've done. I've got this method. It's got parameters that are annotated, right? But it's just a string ID and a string payload. I could use this for anything. I could, if I wanted the map of all the headers, I could inject that as well. I could say, okay, headers map string object. There's that. Now I could inject all the headers as well. So I could say headers dot for each kv system out k. Okay, we start. And again, Spring Negation doesn't care how many parameters I have as long as I annotate them clearly. If you don't specify which payload, which parameter is the payload, I think you can drop this and it'll sort of figure out that, okay, this is the payload. It's supposed to be of type string in this case, or file or whatever, and it'll give it to you. But I just like to be clear, so I use the annotations. Why is this important? It's because you can use the integration flow pipeline style or the annotation style on methods. And you can do this for, there's other annotations like at transformer, right? And at aggregator and at router and a bunch of others, all these different components in Spring Negation, okay? Now, granted, this is pretty tortured, so let's, like me, I like the integration flow style. I think it's just more clear. You can use the implicit channels that we get by using just string names. Spring Negation will create the channels for you. But again, I like to keep my channels typed. I don't like having strings, so I tend to get rid of all that. So let's just clean this up a fair bit, okay? We've gotten way out of control here. So we got too many moving parts, and I want to keep it nice and simple. So inbound flow, okay, get rid of this. Get rid of that. And then that. We don't need the service activator. Get rid of that. And then outbound flow, okay? So now what we want is to have an inbound flow that takes the data in from the file system, okay? And then we're going to say uppercase in, okay? And actually we can just, here's where it's still okay to do bean message channel, uppercase in, turn message channel dot direct dot get. Okay. No, why do I even have, yeah, because I want a different flow. That's right. So then I want uppercase out. Okay. And by the way, in Kotlin, this becomes a one-liner. You can just say fun uppercase out, parenthesis, equals message channels dot direct dot get, right? And have a bean on it and add bean annotation on it. Okay, so inbound data from the desktop goes to this channel, and then we have a integration flow that looks for that. So uppercase flow, turn integration flow dot from uppercase in dot get dot handle new generic handler of type string dot handle uppercase out. So payload dot to uppercase. Okay, so pretty straightforward. Actually, as straightforward as it can get. data in from the file system, put it on a channel. After we've canonicalized the data, as soon as we've canonicalized the data, we put it on a channel that gets sent wherever. We could send it outbound. We could send it to another integration flow. We could do whatever. I then have a little flow that just uppercases it. Pretty trivial. We send the data out on the other outbound channel, or we could use write the outbound. We could use the outbound adapter here directly. But I like to keep my flows, nice and clean and singly focused. So then from uppercase out, from here, we want to take the result of that and just print it out and then write it out to a file system. Okay, pretty straightforward. Now let's go over here. Okay, go here. Yes. So echo hello world to a file called random. The variable that'll give us a random file name. Okay. Oh. Something went wrong, friends. Let's see. Oh, it failed when it started. Okay, so uppercase. What did I do? Okay, uppercase out, uppercase in, uppercase flow. I've had ambiguous parameter message handler. Do I have a message handler in there anywhere? For method? No. Is this? Uppercase flow. Okay. Uppercase flow is having trouble. Bean, integration flow, from uppercase in. Handle. Oh. Okay, sorry. Okay, so now, what if we have an error? Okay, and this becomes another very interesting question, which is how do I route or handle errors in a Spring integration application? So earlier on, I had a simple but trivial example where I had numbers. Well, those aren't letters. You can't really uppercase a number. I mean, maybe you can, but in ASCII Roman text, you can't, right? So let's say I have like a thing where if something goes wrong, I want to validate that we handle that correctly. Okay, so let's create a new channel here called error channel. So bean message channel error channel. Okay, turn message channel dot direct dot get. Okay, and what I want to do is to throw an exception when I've determined that the data doesn't have any letters. Okay, pretty trivial example. So let's say I'm doing a handle. Okay, new generic handler, string in. Okay, so I'm going to throw an exception. So I'll say, okay, what's a good way to do this? Payload dot to car array for var c if character is uppercase is a letter C. If not, throw new illegal argument exception. Actually, we don't say if it's a letter. So var error equals false, error equals true. Okay, so if error, wait, the other way around, good equals true, right? So we say if not good, throw new illegal argument. You must provide some letters. Okay, something like that. I don't know. Pretty boring example, but you get the idea. So I'm going to throw an exception when there's a situation where the messaging code can't do anything useful. Okay, this is a trivial example, but the question then is, what happens to this exception, right? And usually, what happens is Spring Integration sends that message on the error channel that's assigned to the message flow. Okay, and if you don't have one specifically, I think it looks for the default, which is called error channel. So we can create our own error channel message flow. So we say integration flow error. Okay, we say return integration flow from error channel dot handle new generic handler string, or actually let's just do object so you can kind of see what we get. Okay, dot get. But what I'm going to do is I'm going to look at the incoming payload and just kind of debug it, right? So system out inside the error handling flow. So payload headers dot for each kv. We get extra context associated with where the error happened in the headers, right? Out of band metadata information. Okay, so now we've got, let's just echo random. There's no letters in here now. Random to random. And that should throw this. We're inside the error handling message flow. Okay, something went wrong, but we didn't have to worry about the try-catch logic in the processing pipeline itself. Instead, it got sent to this message, this error channel that we created. And you can see all the sort of data about it, right? So messaging hand flow, generic message, payload this is the payload. Here are the headers. So we can see the file, all this stuff that we had in the regular flow. We can see that, but you didn't see me do anything explicit besides throwing an exception. And it's being sent to this. Now, what if I want to have a message channel, error channel for letters, violations, okay? Return message channel dot direct dot get, okay? So now I've got a custom error channel that I want to use specifically for any letter issues, okay? So let's see, go here. And I can go down to, where's my logic? Here. Okay, so I'm going to put it, I'll put enrich headers. Okay. Error channels for letter violations. Okay, channel. Now I'm adding a header, and that will override for this particular flow. It'll override the default global error handling channel. So all exceptions will get routed to error channel unless the integration flow has a particular error channel set on it. And so we need to now create another handler for this. We'll say, okay, for error channel letter violations inside the error, okay, flow. Good, and inside okay, so basically the same code, but we created a fork in the road, right? Where is our inside? Inside the error for letter violations flow. Okay, so you can override the default. The global one is still that. So what if I have another component? Let's say here in the inbound flow, before I've sent it out to the uppercase part where we've added that custom header, let's say I throw an exception here. Okay, let's say we throw new illegal argument exception. You screwed something up. Right? Okay, so I add that. If I don't know why the compiler is so easily confused, but okay, let's say. Okay, so now inside error flow, right? We get the error flow now. Doesn't that create like I'm able to? I can participate. I can have the message go to the error channel, or if it gets into the uppercase flow and I have a particular channel set for that, then I can it'll be sent there correctly as well. Let's see. Do we get access to the exception? Let's try that out in the error flow. Where's our error flow? This one. And this one. Okay, payload is message handling exception. And then the message handling exception has the original message. So if you want, the payload is a message handling exception. You can declare that you want a type of payload of that type, right? And then from there, you have access to the original message that was being sent where the error occurred. And you have access to the exception itself. You screwed something up, right? So I can inspect that and I can go, oh, okay, something happened here. I need to respond to that accordingly, right? This is a nice way to, again, just like in Spring MVC, we saw we have controller advice. This decoupling of your main happy path code from the error handling code is very convenient. And again, if you can inspect the message and decide, okay, you know what, not a big deal, and send it right back to the start line again. Maybe you can change the data, maybe you can act on it. And the outbound of this error flow could just be to another channel. It could be back into the input, right? After you've transformed the data in some way, you could do something like that. So it's easy to build really nice pipelines by just chaining things together like that. Okay, now let's save that. Error handling is, obviously we could talk a lot about that, but git commit errors. Not that you have errors in your code, but for the rest of us, need to worry about that. Okay, let's talk about, I'm trying to keep it all within Spring integration just so we're like on the same page, because the patterns work basically for everything once you start doing actual integration, but you need to understand the patterns, I think. So error handling is one, asynchronous error handling is another. Message channels as a way of like connecting different processing pipelines is something very important here. You can see I'm using channels. Whenever there's a different conceptual sort of bend to a particular thing I'm doing, then I can I tease it out by creating channels as the fiber by which these things can communicate. Okay, inbound flow, uppercase flow. Okay, let's talk about something a little bit more. Let's talk about scatter gather kinds of processing. Okay. So goodbye to all of that. Okay, no more files for a minute. Let's just talk about a regular integration flow. Actually, let's build a domain model. Let's say I have a record of type customer. It has an ID, and I have a name, and I have a set of orders. Okay, a record order, string, skew, whatever. Okay, I've got customers and orders. Okay, and let's say I want to process. Let's say I've got not even customers. Let's do better yet, line items. There you go. Okay, record. Okay, so line items, and this is going to be an order, and we'll say it's whatever. Just get rid of that. We don't need that bit. Okay. So the ID of the order is thus, and the line items for that are here. So let's say I've a user has gone to a website and they've purchased 5 different things. Okay, that's the order. but the order has the ID, the transaction ID that refers to all 5 different purchases. But of course, let's say you're an e-tailer like Amazon or Alibaba or something like that, right? Or JD, right? You need to take each one of those line items and route them to the original merchant if they're somebody else, or you need to like process them yourself or whatever. This involves a pipeline, right? Where you send it to somebody, they get the order, they have to find the actual physical parcel, the actual physical thing, put it in a box, and then send it out for delivery, right? And that whole pipeline takes time, and you want to orchestrate that. This is a natural case where you start with an order. Somebody on the website clicks buy, the transaction is completed, the money is put in the bank account, whatever. But then you take each one of those line items, and each one of them has their own journey, okay? This is a great example of scatter, gather kinds of processing. So let's say I have integration flow, e-tailer flow, whatever. Very, very trivial example, but simple. Okay, return integration flow. So how are we going to do this? We're just trying to use some dummy data here. So maybe we can have a channel here just to keep it simple. So bean message channel. Okay. We're going to call this the orders channel, message channel, .direct, .get. Okay. So I'm going to say when orders come in, we need to do something with them. And what we're going to do is we're going to handle them. Okay. So we're not going to handle them. We're going to split them, right? We're going to split. And so to split, we use this split operator. And the split, there's a lot of different ways to do this. The function of T with a consumer. So a function of T is order, and then line item. What is line item? Is this supposed to be line item? Okay, that's not right. It's going to be a collection of line items, right? So what does split want from me? Method invoking splitter to provide the discovered method of the service at runtime. Split B consumer, blah, blah, blah. Method invoking splitter. Okay. Message processor, method invoking message processor. Just looking for process message. The contract here is okay. So the data is coming in as a function of whatever a splitter. So what is this function supposed to do? That's what I'm trying to figure out here. Let's just try the spec. Okay. I mean, conceptually, we know what we need to do. We need to break it. That's a message header spec. Abstract message splitter. Let's just use that for now. That's an old class that's going to give us nice clear clues about what we're supposed to be doing. New abstract message splitter. It doesn't. Actually, it doesn't. Okay, so abstract message splitter. Where's my abstract method? Abstract. Subclasses, okay. The return value may be a collection or an array. The individual elements may be messages, but it is not necessary. So you can return payloads or messages themselves. So let's try that, okay? Now that we know what's probably okay, we're going to do it this way with the old-fashioned way first. So we'll say message.get payload, right? The payload we expect is going to be the order. And then we're going to return order.line items, okay? Pretty simple example. So system out got the order. Okay, order.id. And I want to send it out on each one of these. Each one is going to have its own flow. So it's going to get sent out. So I'll have if I have 5 line items, I'll have 5 message flows. So now what? Now I need to once it's been split, well, then I need to send the data. I need to handle it, right? Okay, let's say new generic handler. Okay, new generic handler. And now I'm dealing with line items. Okay. And I'm going to stop the flow here, but let's go through the headers. So headers dot for each KV, KV, right? Very good. Okay. Now we need to actually kick off the flow by doing something that generates an order. So I'll just create a little application runner. Okay, return, and I'll say when the application starts up, I'm going to use the orders message channel. Wow. I'll say orders dot send message builder dot with payload and dot build, and the payload will be a new order with 1 and then set of new line item 1, 2, 3. Okay, pretty trivial. Just sending a message into the channel. We'll let the processing pipeline take over and do the work from there. Okay, let's see. Okay, so what did I do wrong? Integration application required a single bean, but 3 were found orders. Oh, it's looking for the wrong channel. Name and type. Orders. Because remember, there's lots of channels in the context. There's the error channel and so on. Okay, so we need to like print out some lines. Okay, so what does that do? Got the order. What about this one? Got the line items. So yeah, see that? It's added sequence numbers. So now each time, right? By the way, you can also do this concurrently. You can also have this like go out to other systems. You can have it do whatever. But now I'm splitting the message that comes in from the order pipeline, right? So somebody clicks on a button on a website, that web component in Spring Web Flux or Spring MVC or whatever, they have a reference to this channel, or maybe they have a reference to that interface that we looked at earlier, right? That interface where you create a messaging gateway. They inject that, they call the method, a message gets created with a customer and the line items. It goes into the integration flow. First thing we do is split it up because we don't have one message. We have 10, right? We have n, where n is the number of line items. We send the message, each line item onward, but notice that we can still see it's got a correlation ID, right? It's got an ID, it's got a sequence size as well. It says there are 3 items and this is item number 2, okay? So, and notice that the correlation ID is exactly the same. So it's able to piece together that this is the batch that ends with 441, and there's 3 items total, and you're looking at item number 1, 3 line items, right? So it's implicitly able to then glue that back together into one group later on. Okay, so I could do whatever I needed to here. I could send this here. I'm just printing it out, but you could easily send it off to RabbitMQ or do some sort of gateway thing, or just send it out and write it to the database, and then have some other processing flow somewhere else pick it up and do something with it. Right? It can get routed to USPS and FedEx and UPS and whatever. You know, whatever. My point is, you can write this flow where each thing now has its own life. But then what happens if you want to like integrate all the data downstream and put it all back together, right? You want to put Humpty Dumpty back together into one big pipeline, okay? Okay, so here, it becomes more useful to have information about the original order as well, right? The order itself. So let's say we have a database here. Okay, I'm just using this as an example. Okay, so integer order db new concurrent hash map. All right, there's that. And I'm going to create a message here. There you go. There's a message. Order message. Okay. Order message. I'm going to create the message with this payload, but I'm going to write that to the database. Let's just pretend this has been something that we wrote to a database before we sent it off in the messaging flow. Okay. So this dot ordersdb.put payload.id and then payload. Voila. And there's that. And here's that. So I'm sending the message after I've written it to the database. Now I have an ID of some sort, some way to look it up again. So I'm going to add set header, right? And then the header will be order ID. Okay. And the order ID will be payload.id. I'm adding a custom header to the message that will get propagated downstream. Okay. So I've got the order ID, etc. So that's very useful. You can encode custom information about the provenance of each line item. So even though you no longer have a reference to the parent order, you can look it up. You can say, okay, well, this line item belongs to this order. That's a business fact that I need. So Spring Integration will help me aggregate them. And in theory, it'll do a good enough job. But just to be sure, now you know on what object Cs need to operate, right? The line items don't contain a pointer to their parent order, but now the message header does. So let's then pull everything back together. Okay, so got the line item. And payload here is just a line item. And then you do an aggregation. Okay. And now what do I have? New generic handler. Okay. After the aggregation. Payload. So let's just see what we get here. Okay, so we got called after the aggregation, right? You can see there's three line items in there. So it's able to split the things apart and then pull them back together again, as long as those headers are in the right place. And in fact, it'll keep state. So then the question then becomes, well, how long does it keep it? What does it do with it, etc. And so that, you start to look into this spec and you start to say, okay, well, is there anything I want to anything I want to do to expire groups upon completion, that kind of thing. Like there's just all sorts of stuff that you have to worry about in terms of like, how long do I want to wait, right? But for the default case, this just works really nicely, right? For things where you're not waiting forever and ever, where you just got like messages that are going from one messaging component to another, and it's all pretty quick. As long as you're not dealing with like a gazillion messages at a time, this is a very, very easy way to do service orchestration. Let's see if I can clean this up. Now that we kind of understand that you can return line items, which is what I thought, but I wasn't sure. I wonder if I can just do a function of order and then return a collection of line items. So new function order, okay, and then this is a collection of line item. Implement those methods, apply, right? So order dot line items. Good. Let's just try that. After the aggregation, there we go. So it worked just fine. So that's exactly what you would do, is you'd do just that little lambda, that method reference. Okay, so very simple, very, very simple example. Obviously, I'm not routing everything through other messaging systems. That's where things get more fun. But now that you kind of understand some of the basics, you've got filters, we've got inbound adapters and outbound adapters, you've got message channels, got error handlers, you've got splitters and aggregators, you've got service activators or handlers, which they're in the DSL. Whenever you see handle, think service activator. That's basically the same use case, right? Yeah, it even says it. Look at that. Populate a service activating handler for the yeah, it's a little, there's a bit of a dissonance because I grew up with Spring integration, from 2007, and in the XML namespace, and in the component model, it was at service activator, and then the XML service activator, service dash activator, but handles the same thing. Okay. What else do you have to care about? We looked at wiretaps ever so briefly, right? Like wiretap. Wiretap is, hey, I don't want to stop the flow, but I want to log it. Okay. So I'm going to give it a reference to either another channel. So let's say bean integration flow or message channel. Let's just do that. Actually, you know what? Let's just do an integration flow. Logging integration flow, right? No, I want to do a message channel. That's better. Logging channel. Okay. Return message channel .direct.get. Okay, and then logging channel. Okay, so send that out. So it's not going to stop the flow. It's just going to give you a chance to intercept it, to audit it, etc. So you go here, bean integration flow, logging flow. Okay, return integration flow dot from logging channel dot get dot handle new generic handler. And then here it behooves you to be as generic as possible. You want payload of object, right? Because you're going to log any message possibly, or if you know this is only going to be used to log this one flow, then yeah, you can depend on a particular type. But tapping, okay, and headers. I've been doing this informally all the time. Whenever you see me do a handle call where I'm doing this, basically I should have been doing this, but I want to save that for this. Okay. Restart. Okay, so let's clean up the rest of this code. We don't need this. It's redundant by definition, because we're wiretapping. You can see it's still doing the aggregation. The message was wiretapped, it went out, and then it came back in. They sent a copy of the message to the logging channel. Everything was copied and sent over that. So we're able to debug it, and we're able to look at it and audit it and all that. But so after the aggregation, okay, tapping, great. Here's this. Yeah, basically that's it. Let's just restart. Okay, after the aggregation, line items, blah, blah, blah. But where's our tap? Does it show tapping? Tapping line items, skew 2, tapping line items, skew 3, etc. So it's very, very convenient to put yourself there. There is also micrometer integration. Remember we had our friend Jonathan Ivanov, micrometer Spring integration, and we talked about it. Is it observation? Let me see, integration flow. Enable integration management. Default logging enabled equals true. Presence of the micrometer meter registry in the application context triggers support for micrometer metrics. To use micrometer, add one of the meter registry beans to the application context. So if you're using Spring Boot and you set up the Spring Boot actuator, you should automatically get metrics, right? That's cool. There are 3 gauge meters that get created for you automatically. Micrometer metrics captor. Okay. If you wanted to disable measurements for a particular channel, say you had this bean called Q channel, it would get the registry, the micrometer registry, config, meter filters, meter filter deny, ID. If the type equals channel and the name of the bean is no meters, which is what this is, then it'll get denied. So you can actually disable it, but it's kind of an all or nothing thing, right? And none of the integration management components So assuming you did @enable integration management, there's an observation pattern. So that gives you what does that give you? It's a customize what set of components. I guess that's the integration flows. So if you set observation patterns equals asterisk, then micrometer will automatically look at all that. I guess you know what, we should revisit that in our next stream, my friends. Good stuff. Good stuff. Inbound. Okay, let's see. Messaging gateway. Message producer support being the inbound endpoint of the flow is considered a consumer span type. Okay, so you also get tracing. That's what this is trying to say. We should look at this in more depth tomorrow. I feel like I want to save this and we'll let that sync. Status. Split. Aggregate. All right, my friend. This was fun. I hope you got something out of it. We're now 2 days into our journey with Spring Innovation. We have looked at a lot of the core patterns. I have this sinking feeling I'm missing something. We looked at wiretaps, splitters, aggregators. We looked at inbound adapters. We haven't looked at gateways, but conceptually, well, we looked at messaging gateways, but you haven't seen me use it to do like a inbound gateway with another protocol. Although you haven't seen me do anything besides files for inbound adapters either. So don't worry, we'll cover both of those in more depth, in more detail soon. We looked at filters. We looked at service activators. We looked at wiretaps. I mean, we looked at a lot of stuff here. Good stuff. All right, my friends. Go watch that bottom video. It's fun. It's more fun than it's silly. It's a very silly video. It's like 20 minutes. It'll be fine. All right, my friends. Have a great day. Thanks again, and I'll see y'all tomorrow.